Hello everyone, welcome to this video on grid search implementation by Intellipaat. Grid search is a technique for optimizing machine learning models by testing different combinations of hyperparameters and selecting the best one out of them. In this video, we will dig into the implementation of GridSearchCV and its underlying principles. But before we begin, please make sure to hit the subscribe button and click the bell icon so that you won't miss any updates coming from our channel. Okay guys, so here first of all what we are going to do is upload a sample data that we have, and then we will try to understand that data, like what all the features are there in that data and what will be going to our target variable. And after that we are going to use an ML algorithm and see the accuracy score that the ML model will give. And only after that we will be going to our main step, which is hyperparameter tuning using GridSearchCV technique, right? So let's first start with uploading our data set that we have. For that, first of all, we need to import pandas. So let's import that first. We will write here import pandas spd. So as we import this, our pandas library, we have to import our data set. So for that, we will write df equals to pd.read_csv, and then the CSV file name of the dataset that we have. In my case, it is smoking.csv. So here I'm uploading the smoking dataset that I have. Now let's try to execute this statement and we'll see. Okay, it executed successfully. Now let us try to print the head of our dataset that we have uploaded here. So this will give an idea of how our data set looks like. So let's try to execute this. So here we can see the top 5 rows in our data set, and we can also see that there are 27 columns in this data set, right? And these are all the columns in this data set, right? So let's also try to print the shape of our data set. So this will give an idea about how many rows and how many columns are there in our complete data set, right? So let's try to print that first. So for that, we will write df.shape. Let's try to execute this. So here we can see we've got an output 55,692,27, which means in our data, we have 55,692 rows and 27 columns. So this is the shape of our data set, right? So it's a very good amount of data that we have to train or test our ML model, right? But for the sake of time and for this video, we will be using a very small part of this data, and using that data, I will show you the complete implementation part. Because if I try to implement it on the complete 55,000 plus data rows, it will take a hell lot of time. So I will be just using a small part of the data set and show you the implementation and working of GridSearchCV, right? So let's use the top 400 rows from our data set, and we will save that in a variable named data. So let's do that. So we'll write here data equals to df.iloc, and we will give here colon, then 400. So we are keeping data till 400th row, and after that all of the rows will get deleted, and this data set will get stored in our variable named data. So let's execute this. Okay. Now let's try to check the shape of this data which is stored in variable named data, right? So let's see that. Now here we have 400 rows and columns are same, it is 27, right? Now let us check the info of this data which is present in this variable called data variable. So let's check that. So here is the data, and we can see these are all the columns that were available in our data set, right? And here we can see the data types of those columns. So here we can see that column name gender, column name oral, and column name Tartar. These 3 columns are not in a numeric form, right? Means the values that are present in these columns are not in numeric form. So first, what we have to do is we have to change these columns into a numeric form. So first we have to do that, and to do that, what we have to do is first of all we have to import label encoder from scikit-learn.preprocessing library. So let's write that first. So we will write here from scikit-learn.preprocessing, and then we will write here import label encoder, right? And then what we will do, we will write variable name. I will give here le, and here we will write label encoder, right? And now here we will pass all the column names for which we have to change their data type. So I will write here first, that is gender column equals to le dot fit underscore transform, this one. And then here I will pass again data and column name gender. So the same thing we have to do for other two columns also. So let's do that. So I will change the name of column here. Next one is oral, this one, which is in object form, and tartar, which is also in object form. So here oral, and here I will write TAR, tartar, right? And the same here oral, tartar, right? Now let's execute this part. Okay, this part successfully executed now. Now let us again check data.info. And now here we can see that column name gender is now in type. Column name oral is also in type. Column name tartar is also in type, right? So these three were here of object types before, and now they are of int type. So now all of the columns that were present in our data sets are of numeric type, right? Now next what we have to do is we have to extract features and set the target variable. We will write x here equals to, and here we will exclude ID and smoking column, and rest all columns will be added as a feature in this. So we will write here data dot drop, and then we will write here ID, then smoking. So what we are doing is we are excluding these two columns, and rest all the columns will be there only. And we will write here x is equals to 1, right? And next we will write y equals to data and then the column name. So here we are basically adding our target variable. So in the target variable we are adding smoking as our target variable. Now let's try to execute this statement. So it executed now. Now after that, what we have to do is we have to split our data for training and testing set. So we will write here x underscore train, x underscore test, y underscore train, y underscore test, and then we will write train underscore test underscore split, and here we will pass x comma y, and we will give it a test size. I'm passing here 0.2, and then a random state. I'm giving here 42. Okay, so before we execute this part, we have to also import train test split module from scikit-learn module selection. So we will write here from scikit-learn dot module underscore selection import train underscore test underscore split. So first we have to import this, and then we have to, so let's execute this part now. Okay, there is an error, so it's a type error. Okay, so there is a spelling mistake here. Now let's try to execute that again. It executed successfully now. Now what we have to do is we have to use an ML algorithm and fit this data to that model, and we will see what accuracy we are getting from that ML model. So I will be using the random forest classify algorithm here. So let's import random forest classifier and accuracy store from scikit-learn library. So for that, we will write here from sklearn dot ensemble, we will write import random forest classifier. And then we have to also import accuracy score. So we have to do that from sklearn matrix. So I will write here sklearn dot matrices and then import accuracy score, right? And then we will store our random forest model to a variable. I will write here RFC equals to, I will store the random forest model in this variable. And then I will write here RFC dot fit x underscore train y underscore train. And then we will predict that ypred equals to RFC dot predict. So we are basically trying to predict here using our random forest classifier. And then here we will print the accuracy score. So that's why we have imported accuracy score y test comma y underscore. Is there any error? Accuracy score. Okay. Let's try to execute this part now. Okay. So here we get an accuracy percentage that is 77.5%. So we are getting this accuracy score directly by using random forest classifier model in our data. Right. So now we came to our main part of the implementation, and that is hyperparameter tuning using GridSearchCV technique. So before we do that, let us see what our hyperparameters and grid search techniques basically are, right? Okay, so if we are talking about hyperparameters, what are they basically? So hyperparameters are nothing but they are knobs and dials which we can use to control the behavior of a machine learning algorithm. And these are not learned from the data, but instead we have to set them manually before we train the model. So let us try to understand this with a simple example. So just imagine that you are baking a cake, right? Here, the recipe of making cake is like the machine learning algorithm, and the ingredients that we need are like data. But to make a perfect cake, we need to adjust certain settings like oven temperature or baking time. And these settings are like the hyperparameters here. And if we are talking about hyperparameters, there are different types of hyperparameters that we can pass while training our model, like learning rate, and estimators, max depth, min samples split, n clusters, and there are many more hyperparameters like this. Like see, if you are passing learn rate hyperparameters, what it basically does is it controls the step size during optimization. And if you are passing max depth, it basically decides the maximum depth of a decision tree. So like these hyperparameters, there are many more hyperparameters that were there and will be used while training the models. Now let us see what is grid search and working behind it. So as I said, grid search is basically a method for hyperparameter tuning in machine learning. And it involves in systematically evaluating different combinations of hyperparameter values and selecting the correct set of values that produces the best results. So just imagine that you have a model that predicts the price of a house based on its size, number of bedrooms, and number of bathrooms. So you want to find the best combination of hyperparameters for these models, such as the number of trees in a random forest or the regularization parameter in a linear regression model. So grid search basically works by creating a grid of hyperparameter volumes. For example, you might try different values for the number of trees in a random forest, such as 10, 20, 50, and 100. And then you would train the model on the training data using each combination of hyperparameter values and evaluate its performance on the validation data. And this combination of hyperparameter values that produces the best performance on validation data is then considered the best set of hyperparameters for the model. So here is the simplified overview of how grid search basically works. It starts with defining the hyperparameter grid, where we have to specify the range of values for each hyperparameter that have to be evaluated. Then it moves to second step, that is train and evaluate models. Here, for each combination of hyperparameter values, we will train the machine learning model on a training dataset and evaluate its performance on a separate validation dataset. Then it moves to the third step, which is selecting the best parameters. Here, we have to identify the combination of best hyperparameter values that yields the best performance on the validation dataset. And then, so here at last, we have to train our model again using the selected parameters on the training dataset to obtain the final model. So if we are talking about grid search, it is a valuable tool for improving the performance of machine learning models, but by carefully selecting the appropriate hyperparameters which can enhance the accuracy, precision, and overall effectiveness of our models. Now let's jump back to our implementation part, and we will do there the rest of the implementation part using our GridSearchCV technique. Okay, now let's start our hyperparameter tuning part that we were doing using GridSearchCV technique. So first of all, we have to import GridSearchCV library from scikit-learn model selection. So we will write here from sklearn.model selection, and then we will import GridSearchCV. Let's try to execute this now. It executed. Now here we have to pass the hyperparameters for this machine learning model. So we will write here forest underscore params here, and we will pass the hyperparameters here. So let's pass some of the hyperparameters that will tune this model and give us a better accuracy than this one. So our aim is here to get a better accuracy than this one using some of the hyperparameters. So I will pass here my first parameter, that is max depth, and I will pass here some values. I'm passing here a list ranging from 10 to 15, and then I will pass another hyperparameter, that is max features. So as you all know, in this dataset we have total of 27 features in this dataset, that is 27 columns in this dataset. So here we can select how many maximum features that we want. So I am selecting here a range. So I will pass here 0 to 14. So I'm not selecting all the features that I have in my dataset. I'm only passing till 14th. Now let us write CLF equals to grid search. So I'm adding grid search here now. GridSearchCV. I will pass the model name, that is random forest, which I have stored in RFC, and then the hyperparameters that I have stored in this variable forest params, right? And then CV equals to, I will pass 10 here, and then scoring equals to accuracy. And here we have to fit that. So I will write here x underscore train and y underscore train. And then I will print CLF dot best parameters. And then I will print CLF dot best score. Now let's try to execute this part. Okay, so as you can see, this part is now executed, and here we got our best parameters and our best score. So as you can see that execution of this part only takes 2 minutes, and this is the reason why I have chosen only 400 data rows from our data set, because using the complete 55,000 plus data rows will take more than 1 hour or 2 hours of time to execute this part here. So that is the reason why I have chosen a small part from that data set. So now as we got our best parameters and best scores here, let us try to print the accuracy score that we got after this hyperparameter tuning using GridSearchCV. So let's try to print our accuracy score here. I will write my predict equals to clf dot predict x underscore text, and I will write here print accuracy score, and I will pass here y test y predict. Let's execute this now. Okay, so here now you can see we got the accuracy of 80%, and above here we got the accuracy of 77.5%. So you can see how the accuracy got changed from 77.5% to 80% just by training with some different kinds of hyperparameters that you can see here. We have trained with these hyperparameters, and by training with these hyperparameters, we got a change of nearly 4 to 5% in our accuracy, right? So there you go. You have seen how passing a certain hyperparameters have actually changed the accuracy of AI model from 77.5% to 80%, right? So that is what the GridSearchCV technique is using the hyperparameter tuning. So that's all we have for this video. I hope you got a good understanding about what is grid search and how to implement grid search using hyperparameter tuning. Thanks for staying with us till the end, and if you found this video helpful, please give it a thumbs up and share it with your fellow mates. And also make sure to subscribe to our Intellipaat YouTube channel so that you won't miss any updates coming from our side.
Just a quick info guys, Intellipaat offers machine learning course in collaboration with IITM Pravartak. Through this course, you will learn various algorithms and machine learning techniques such as supervised, unsupervised learning, natural language processing, and much more from the IIT Madras faculty and industry experts. With this course, we have already helped thousands of professionals in successful career transition. You can check out their testimonials on our Achievers channel, whose link is given below in the description. Without a doubt, this course can set your career to new heights. So visit the course page given below in the description and take a first step towards career growth in the field of machine learning.